The equivalent resistance is the resistance of several resistors taken together. It depends on the value of each resistor and on the configuration of the resistors. Here we have a picture of various carbon resistors. For circuits in series, the equivalent resistance, that is, you might say the resistance perceived or sensed by the battery, is simply the sum of the resistances. So if we have resistor 1 and resistor 2 and resistor 3, you can see those are all in series. The resistance felt by the battery, if these three resistors were in that circuit, would be the sum of these. That resistor also is in series. Let's do a couple of examples. These are what I call circuit Sudoku problems, where we're given a schematic diagram of the circuit and we're given some information about the circuit. The potential difference here across the battery, this is a 24 volt battery, and the resistances of each of the resistors are given. Like Sudoku, there is no one correct place to start. You just fill these boxes in as best you can, using the rules for the circuit configuration that you have, and the understanding that for every row, Ohm's law must be satisfied. V equals I times R. V equals I times R. So, for any row, if you know two of the values, you can easily find the third from Ohm's law. These resistors are in series, so the resistance felt by the battery is simply the sum of those, 4 plus 6 plus 2. Ohm's law must be satisfied across this row, so 24 equals the current through the battery times the resistance felt by the battery. Hopefully you can do that in your head. 2 amps. So we have 2 amps of current traveling through the battery. Since this is a series circuit, the current through all the resistors must also be 2 amps. So we can fill in the rest of these middle boxes. And now we can figure out the pressure difference or the color difference across each resistor by using Ohm's law. V is equal to I times R for each row. 2 times 2 is 4, 2 times 6 is 12, 2 times 4 is 8. And there you have it. If we go a bit further and pressurize the wires with voltages, we know that this wire is the highest pressure and the wire in the lower left is the lowest pressure. Lowest pressure, if we assign that as 0 volts, and this is a 24 volt battery, then the color of this wire in the upper left must be 24 volts. Well, if we look at our table, the pressure difference across resistor 1 is 4 volts. So if it's 24 volts on the left side of resistor 1, then on the right side of resistor 1, the color of that wire must be 20 volts. If we look at the table for resistor 2, the pressure difference across resistor 2 is 12 volts difference. So for resistor 2, if it's 20 volts up top, it must be 8 volts on the bottom. And you can see in the table that resistor 3 has an 8 volt pressure difference across it. Let's do another one. This time we're given the values of the currents as well as the voltage difference across the battery and the voltage difference across resistor 2. We've said that if you know any two of these three in a row, you can very easily find the third. So the battery perceives 10 ohms of resistance. Resistor 2 is a 4 ohm resistor. Since these resistors are in series, we can easily find the resistance value of resistor 1, and then 1.5 times 6 equals 9, right? V equals I times R. If we color code these wires with voltages, we'll get 0 volts for low pressure blue, 15 volts for highest pressure red. Then in our table, we see that the voltage difference across resistor 1 is 9 volts difference, which means the color of the wire in the upper right portion must be 6 volts of color. Also for series circuits, and these are more ideas than equations, we know these already. The current through any resistor is equal to the current through any other resistor, and the voltage drop, the voltage difference across the battery, is equal to the voltage drop or the voltage difference across each resistor. Final thoughts on series circuits. In a series circuit, the resistance elements are in a one after the other configuration. The current has no choice but to go through one resistor, then another, and so on. There is only one path for charge flow. The equivalent resistance is the combined resistance of two or more resistors connected somehow. For series circuits, the equivalent resistance is the sum of the individual resistances. Because there is only one path for charge flow, all circuit elements in series circuits have the same current.